This is example 1. It says draw the following angles in standard position. And so by standard position they mean in a coordinate plane with an XY axis where the positive x-axis is considered 0 degrees. So anything out here is 0 degrees. Anything at y is 90 degrees. The negative x is 180 and the negative y is 270. So standard position angles always start at positive x and they always rotate counterclockwise. And so for 120 degrees that's greater than 90 but less than 180 of course. 120 degrees is right in here somewhere. And negative angles start at the positive x-axis, which is 0 degrees, and they go clockwise. And so 240 is greater than 180, and it turns out that these are the same, that they end up on the same line. And so these two angles are what we call coterminal. And so if you remember, for any angle that we draw in the coordinate plane, we have the initial side, which is the positive x-axis. We call that the initial side, and where the angle terminates, for example 120 degrees, we call that the terminal side. So every angle has an initial and a terminal side, and the angles 120 and negative 240, they share the same terminal side, and we call those coterminal. These are coterminal angles. Let me give you some more examples. So for example, negative 40 degrees, which started at the positive x-axis and rotated clockwise because it's a negative angle. Negative 40 degrees and positive 320, they are coterminal because they share a terminal side. Let me give you one more example. So let's say 60 degrees and let's say 420 degrees, which is one complete rotation, which is 360, plus another 60 degrees would take us to 420 degrees. And so 60 degrees and 420 degrees, they are also coterminal. Now, we would normally call this 60 degrees rather than 420 because we want our angles generally to be less than 360. If we've made one complete rotation and our angle is greater than 360, we can subtract 360 at 420 minus 360, and we will get 60. And so 60 degrees and 420 degrees are coterminal. Consider any angle in the coordinate plane, and the exact angle is not important, but any angle in the coordinate plane that has its initial side, and we'll call the angle theta. Any angle has its initial side and its terminal side. Now the terminal side is a line, and it's made up of an infinite number of points. Lots of points make up this line all down through here. And if we knew just one point on this terminal side, and it doesn't matter which point we know, any point on the terminal side gives us an x coordinate and a y coordinate. And so this point, we'll call it P, has an xy coordinate. And if we look at the point P with its x coordinate and its y coordinate, we can see that using the x-axis out to point X up to any point on the line forms a right triangle. And the length of this side of the triangle is whatever the x coordinate is. Right, so if x happened to be 6, the length of this side of the triangle would be 6. So the length of this side is x, and the length of this side is whatever the y coordinate happened to be. So the length of this side is also going to be y. This side, of course, is the hypotenuse. It's opposite of the right angle. This is example 2. It says draw the graph of an angle in standard position whose terminal side passes through the point negative 2, 5. And so if we look at an xy plane, Negative 2 is the x coordinate, so that's going to be to the left. It's negative 2. And y is the y coordinate. I'm sorry, 5 is the y coordinate, I mean. And so the point on the terminal side passes through negative 2 comma 5. And so again, x is the initial side. The terminal side passes through this point, which is P, which has coordinates negative 2, 5. And that terminal side forms some angle with the positive x-axis that we call theta. And so we've graphed it. Label that as y. Now again, this angle forms a right triangle with the x-axis, right here. And the length of this side of the triangle is 2. The length of this side of the triangle is 5. And so if I just draw the triangle, I suppose technically I should say that the length of this side is negative 2. The length of this side is 5. This side is the hypotenuse of a right triangle. And we can always find the hypotenuse of a right triangle using Pythagorean theorem. The hypotenuse we oftentimes label as r. And so we can say that r is equal to the square root of the x coordinate, which is negative 2, squared, plus the y coordinate, which happens to be 5, squared. And so if we want to find the length of the hypotenuse formed by this triangle, we will take the square root of, in parentheses, which is very important, this has to be in parentheses, negative 2 squared plus 5 squared. This has to be in parentheses because negative 2 squared without parentheses is negative 4, whereas negative 2 in parentheses squared is positive 4. And so anytime we square a number, we want to square the entire value of x, which includes the negative. Okay, so we need the parentheses to do that. We mean negative 2 times negative 2, which is positive 4, whereas this means 2 times 2, and then make that answer negative, which would be negative 4. So we want to make sure we always use parentheses. So negative 2 times negative 2 is positive 4, and 5 times 5 is 25. And we add these together, and we get 29. Okay, and this is a radical that does not reduce. We could leave it in a radical form just like this. We could find the decimal representation if we wanted. That would only be an estimate. And so if we took the square root of 29, we get 5.385164807, and this goes on forever and never repeats. And that's why we do not prefer this decimal representation. I'd much rather you left this as square root of 29. Let's again consider any angle in the xy coordinate plane. I'm just going to draw the first quadrant here. Any angle in the xy coordinate plane, and it passes through an infinite number of points, but we'll just pick one of these points. And this point has a coordinate of some xy coordinate. And so this is the x coordinate, this is the y coordinate, and this forms a right triangle right here, and the length of this side of the triangle is whatever the x coordinate of our point is. The length of this side of the triangle is whatever our y coordinate of the point is, and this side is the hypotenuse. We'll label that as r. And we've already seen that r is the square root of x squared plus y squared. That's Pythagorean theorem. And the angle formed is this angle here. And let us look at the trig functions for this angle. So for example, the sine of theta. The sine of theta is defined as the opposite divided by the hypotenuse. And if you look at theta, the opposite side is y. The hypotenuse is r. Okay, and so if we have some angle in the coordinate plane, and we know that it passes through some point, when we know the xy points, we can determine the sine of theta because we know y. We can find r by using the Pythagorean theorem, and when we divide y by r, we get the sine of that angle. We can do the same thing with cosine. Cosine of theta is the adjacent over the hypotenuse. For theta, the adjacent is the x coordinate. R, of course, is the hypotenuse. The tangent of theta is the opposite over the adjacent, where again the opposite side is y, the adjacent side is x. We can find the cotangent of theta, which is the adjacent over the opposite, which will be x over y. We can find the secant of theta, which is the hypotenuse divided by the adjacent. The hypotenuse is always r. The adjacent side is always going to be x. Oops, I'm sorry, x. And the cosecant of theta, which will be the hypotenuse over the opposite. Hypotenuse is r, and the opposite side is y. And so, again, for any angle in the coordinate plane, if we know any point that the terminal side passes through, we can determine the 6 trigonometric functions because we already know x and y. We can find r using the Pythagorean theorem, and then we can determine the value of the 6 trigonometric functions using x, y, and r. And I should make a few notes here that here x cannot be equal to 0 because I can't divide by 0. Also y cannot be equal to 0. And same thing here, x cannot be equal to 0 and y cannot be equal to 0. Now much less common is that the hypotenuse of the triangle would be 0, which is very uncommon. That would be a point right on the origin. That's the only way the hypotenuse could be 0. But just for good measure, I'll say that the radius cannot be equal to 0 for the sine and the cosine. This is example 3. It says given the point 2, 3, find the values of the 6 trig functions. And so let me start by drawing the point. We have the x-axis and the y-axis. Again, I'm only drawing the first quadrant. And we have a point at 2, 3. And so right here, I have point 2, 3. And that is a point that the terminal side of the angle passes through. And here's the angle. This is theta. And so a right triangle is formed, where the right angle is here. And so to do this, the first thing we need to do is find the length of the hypotenuse. So we know that the length of the side here on the x-axis, the length is 2. The length here that corresponds to the y-axis, the length is 3, and we want to find the length of the hypotenuse. So the length of the hypotenuse will be the square root of x squared plus y squared, which will be 2 squared plus 3 squared, which will be the square root of 4 plus 9, which is the square root of 13. And again, I want to leave this written as the square root of 13. I can use my calculator to try to find a value, a decimal value for the square root of 13, but I'll get a never-ending, never-repeating decimal, and this is going to be much cleaner for us to do. So the length of the hypotenuse is radical 13. The sine of the angle is always going to be y over r. The y value is 3, right? That's the length of the opposite side of the angle. So that's the y value is 3. The hypotenuse is radical 13. Now, because radical 13 is represented by a decimal that is never ending and never repeats, we want to try not to have any radicals in the denominator. And so to get rid of this radical 13 in the denominator, we multiply by radical 13 over radical 13. And so anytime you square a radical or you multiply it by itself, that cancels the radical and we get 13. And in the numerator we will have 3 radical 13. So this is the form that we prefer, where the radical is in the numerator rather than the denominator. And so this will be our answer for sine. The cosine of theta is x over r. Here the x value is 2. R is radical 13. And again, we do not want radicals in the denominator, so we'll multiply by radical 13 over radical 13. Radical 13 times radical 13 is 13. And then the numerator will be 2 radical 13. We'll find the tangent of theta, which is y over x. Right, so y is the opposite side, x is the adjacent. That's the definition of tangent. The y value is 3, the x value is 2. We don't have any radicals in the tangent in this example, so that'll be fine. That'll be our answer. The cotangent of theta is x over y, which is just the reciprocal of the tangent. Right, so x is 2 and y is 3. We'll have 2/3. Then the the secant of theta is going to be r over x, where r is radical 13, and the x coordinate is 2. Here the radical is already in the numerator, so that'll be fine. And then the cosecant of theta, which is going to be r over y. R is radical 13, and y value is 3. Again, the radical is in the numerator, and so this will be our answer. So let's consider two triangles in a coordinate plane that share a common angle. I'll call that theta. And so let's say here's one point on the terminal side of this angle, and we'll call this point P. It has an xy coordinate. And let's call this point on the same terminal side, let's call this R. And so I only have one terminal side, but I've picked two different points. There's an infinite number of points along this line. And each point forms a right triangle. And so these triangles are similar because they both have angle theta, they both have angle 90 degrees, and that means that the third angle of each triangle must also be equal, because all three angles of the triangle have to add up to 180. And so these are similar triangles. They have all of the same angles, and we can prove in geometry that for similar triangles the lengths of their sides are proportional, meaning that if you double the length of the hypotenuse, you're also doubling the length of this side, and you're also doubling the length of this side. And so the length of the sides are going to be proportional. Let's consider P as 3, 4. And let's consider R as 6, 8. And now let's find the values of the 6 trigonometric functions for each one of these triangles. Right? There's two triangles here, and they're similar. Let's find the trig functions for each of the two triangles. So let's say that for the triangle that's formed by point P, we have the sine of theta, which is opposite over hypotenuse. And so for theta, the opposite side is 4, right? This side of the triangle is 4. This side of the triangle is 3. And, oh, well, we need to find the hypotenuse first, right? So let's find the hypotenuse. The hypotenuse of the P triangle will be 3 squared plus 4 squared. The hypotenuse will be the square root of 9 plus 16, which will be the square root of 25, which is 5. So the hypotenuse of the smaller triangle is 5. So the sine of theta is the opposite over the hypotenuse, that's 4/5. The cosine of theta is the adjacent over the hypotenuse, which will be 3/5. And so remember, the opposite side is always the y value. The adjacent side is always the x value. The tangent of theta will be opposite over adjacent, which will be 4/3. The cotangent of theta will be the adjacent over the opposite, which will be 3/4. The secant of theta is the hypotenuse over the adjacent, which will be 5/3. And the cosecant of theta will be the hypotenuse over the opposite, which will be 5/4. Okay, and now let's look at the bigger triangle, triangle R. First we need to find the hypotenuse of triangle R. And so we'll have the square root of x value, which is 6. That's the length of this side of the triangle. So for the big triangle, the adjacent side is 6. The opposite side, the y value, is 8. And so the hypotenuse will be 6 squared plus 8 squared. That'll be the square root of 36 plus 64, which is going to be the square root of 100, which is 10. So the hypotenuse for the big triangle is 10. And so for triangle R, the sine of theta is the opposite over the hypotenuse. The opposite side is 8. The hypotenuse is 10. But notice that this fraction reduces, right? Over here the fractions didn't reduce, but here it does. And so 8 over 10, these both can be divided by 2. That reduces to 4 over 5. And notice we get the exact same answer as we had for sine here, right? The sine of theta is 4/5 for both of these triangles because they're similar. And the cosine of theta will be the adjacent over the hypotenuse. The adjacent side is 6. Hypotenuse is 10. And again, this fraction reduces to 3/5. And again, we got the exact same answer as we had for the smaller triangle. The tangent of theta is the opposite over the adjacent, which is 8 over 6, which reduces to 4/3. And again, we get the same answer for tangent. Cotangent of theta is the adjacent over the opposite, which is 6 over 8, which reduces to 3 over 4. Again, the same answer we had for the smaller triangle. The secant of theta is the hypotenuse over the adjacent, which will be 10 over 6, which reduces to 5 over 3. Again, the same answer we had for the smaller triangle. And the cosecant of theta is the hypotenuse over the opposite, which is 10 over 8, which reduces to 5 over 4. And again, we got the exact same answer. And so what we're doing here is we're proving that the 6 trig functions, the values of the 6 trig functions, the answers we got here, do not actually depend on the lengths of the sides of the triangle. They only depend on the angle. And so I think we can agree that both triangles have the same angle, that theta is the same angle for the small triangle or the big triangle, and that the lengths of the sides do not actually determine the values of the 6 trig functions. Rather, the angle itself determines the values of those 6 trig functions. So no matter how big or how small this triangle was, as long as the angle theta was a constant angle, however we calculated the sine, the cosine, and the tangent, we would have gotten the exact same answers every time. And it did not matter how big or small the triangle was. Let's review for a moment what reciprocals are. Reciprocals are two numbers that when we multiply them together equal 1. So for example, 2 times 1/2 are reciprocals because when we multiply these together, 2 times 1 is 2, and 1 times 2 is 2, and this reduces to 1. So 2 and 1/2 are reciprocals. Same thing as, for example, -3 times -1/3. These are reciprocals because -3 times -1 is +3, and 1 times 3 is 3, and again this reduces to 1. So reciprocals are any two numbers that when we multiply them together give us 1. Now consider the sine of an angle, which is defined as the opposite over the hypotenuse, which could also be defined as the y-coordinate of a point that the terminal side passes through, divided by r, which is the hypotenuse. And consider cosecant theta, which is defined as the hypotenuse divided by the opposite, which is r over y. And so what that means is that sine theta times the cosecant of theta is equal to 1, because the sine is y over r, the cosecant is r over y, and when we multiply these together we get r times y over r times y, which reduces to 1. And so the sine and the cosecant are reciprocals of one another. And so let me rewrite this. The sine of theta times the cosecant of theta is equal to 1. And so I can divide both sides by the cosecant. And if I do that, I will get the sine of theta is equal to 1 divided by the cosecant, which is a true statement. And so that is because the sine of theta, again, is y over r. And this should be equal to 1 divided by the cosecant, which is r over y. And when I divide by a fraction, I multiply by the reciprocal. That's the rules for dividing fractions. And so instead of 1 divided by r over y, this is the same as 1 times y over r. And 1 times any number is itself. And so y over r, which is the sine of theta, is equal to y over r, which obviously is equal. And so that proves that the sine of theta and the cosecant of theta are reciprocals of one another. And so we can summarize that the sine of theta is equal to the 1 over the cosecant of theta. The same will be true that the cosecant of theta is 1 divided by the sine of theta. And I can prove this in exactly the same way. Same thing is true for the cosine of theta. that is equal to 1 divided by the secant of theta. And again, I could prove this in exactly the same way. And that means that the secant of theta also must be equal to 1 divided by the cosine of theta. And then finally, the tangent of theta is equal to 1 divided by the cotangent of theta. And that means that the cotangent of theta must also be equal to 1 divided by the tangent of theta. And so we call the 6 trig functions reciprocals of one another, right? Sine, cosine, and tangent have reciprocals of secant, cosecant, and cotangent, and they are reciprocals of one another. Let's look at the sign of the value of the 6 trig functions, whether they're positive or negative, depending on which quadrant the terminal side of the angle lies in. And so, just to review, the coordinate plane is divided into 4 quadrants. The first quadrant is when x is positive and y is also positive. So the first quadrant is when x and y are both greater than 0, they're positive. The second quadrant is when y is positive but x is negative, so x is less than 0, so it's negative, but y is greater than 0, so it's positive. In the third quadrant, x and y are both negative, so x and y are both less than 0. And in the fourth quadrant, x is positive but y is negative, so x is positive and y is negative. Now, if we know that r is equal to the square root of x squared plus y squared, and anytime I square a number, even if the number is negative, this is why the parentheses are important. If I square a negative number, I get a positive number, and so the r value is always going to be positive. Even if x and y were both negative, when I square them, I get positives. I add them together, I get a positive, and when I take the square root, I get a positive. So r is always positive. So in the first quadrant, the value of sine, if we had an angle in the first quadrant, if y is positive and r is always positive, the sine in the first quadrant will give us a positive number. In the second quadrant, the sine will also still be positive because the y value is still positive in the second quadrant. So a positive divided by a positive still gives us a positive. But in the third quadrant, when y is negative, if we take a negative divided by r, which is always positive, we're going to get a negative answer. And the same thing is true for the fourth quadrant. In the fourth quadrant, the y value is negative, and so a negative divided by a positive is a negative. Now for cosine, in the first quadrant, x is positive, and so x divided by r will give us a positive. But in the second quadrant, x is negative, and so a negative divided by a positive is a negative. In the third quadrant, x is still negative, right? X is still less than 0, so we're going to get a negative value for cosine. And in the fourth quadrant, x is positive again, and so positive divided by a positive is a positive. And so wherever the terminal side lies, whichever quadrant, we can predict if the values of sine, cosine, and tangent and so on will be positive or negative. And I'll go ahead and continue to do this. The tangent in the first quadrant, x and y are both positives, and so when we divide them we get a positive. In the second quadrant, y is positive but x is negative, and so if we divide a positive by a negative, we get a negative. In the third quadrant, x and y are both negative, and so when we divide x and y and they're both negatives, we will get a positive value. And in the fourth quadrant, x is positive and y is negative, and so a negative divided by a positive will give us a negative. Now the cotangent is x divided by y. If x and y are both positives, we get a positive. If x is negative but y is positive, we'll get a negative. If x and y are both negatives, we will get a positive. And if x is positive and y is negative, we will get a negative. And so for secant, r is always positive, and x is positive in the first quadrant, that's a positive. X is negative, though, in the second quadrant, that'll give us a negative. And x is still negative in the third quadrant, so we'll get a negative. And then x is positive again in the fourth quadrant, and so we'll get a positive again. And then finally cosecant is r divided by y. Y is positive in the first quadrant, so a positive divided by a positive is positive. Y is still positive in the second quadrant, and so we have a positive divided by a positive, which is a positive. In the third quadrant, though, y is negative, and so a positive divided by a negative is a negative. And in the fourth quadrant, y is negative, and so a positive divided by a negative is still a negative. Notice that the sine and the cosecant, which are reciprocals of one another, they have the same sign. depending on which quadrant they're in, right? They're both negative in the fourth, they're both negative in the third, positive in the first and second. Cosine and secant are reciprocals of one another. They have the same sign, depending again on which quadrant they are in. And the tangent and the cotangent are reciprocals of one another, and so again they have the same sign depending on which quadrant they're in. We saw the sign of the six trig functions when the terminal side of an angle falls in one of the four quadrants, but the terminal side of the angle could also fall directly on an axis. For example, 0 degrees would fall directly on the x-axis. 90 degrees falls directly on the positive y, 180 degrees falls directly on the negative x, and 270 degrees falls directly on the negative y. So if we pick any point on a terminal side that, say, lies on the positive x-axis, the x value will be some positive number, but the y value is 0. And if the terminal side for a 90 degree angle falls on the positive y-axis, the x value is 0 and the y value is some positive number. At 180 degrees, if the terminal side is 180 degrees, the x value will be negative, whereas the y value will be 0. And if the angle is 270 degrees, the x value will be 0, but the y value will be some negative number. And so what are the signs or values of the six trig functions when the terminal side falls on one of these sides? Keep in mind that r is always a positive number. And so let's first look at 0 degrees. If we had an angle of 0 degrees, or 360, because that's the same terminal side, the r value and the x value are equal, right? So on 0 degrees, the r value is equal to the x value. The hypotenuse of this triangle, which doesn't look much like a triangle because it's flat, is equal to the x value. And so the sine of 0 degrees will be the opposite side, which is 0, divided by some r value, and 0 divided by any r value is going to be 0. 0 divided by any number is 0. For the cosine, which is the adjacent side, or the x value, divided by the hypotenuse, and the x value and the hypotenuse are equal over here, when we divide them we will get positive 1, because they're equal to one another. For the tangent, if we take the opposite side, which is 0, and we divide by the adjacent side, which is some positive value of x, we're going to get 0, because 0 divided by any number is still 0. Now when we look at cotangent, cotangent is the adjacent side divided by the opposite. The adjacent side is some positive value x, and the adjacent side, or the opposite side I mean, is 0. And so some positive value x divided by 0, that's undefined. So the cotangent of 0 degrees is undefined. We cannot divide by 0. The secant is the reciprocal of the cosine, and so the secant is going to be the hypotenuse divided by the x value, and again the hypotenuse and the x value are equal over here, and so when we divide them we will get 1. And the cosecant is the reciprocal of the sine, and so it's going to be the hypotenuse divided by the y value. The y value is 0, and again if we divide by 0 we're going to get undefined. Okay, now what about for 90 degrees? What is the sine at 90 degrees? At 90 degrees, the y value is equal to the hypotenuse, and the x value is 0. And so at 90 degrees, the y value is equal to the hypotenuse. So the sine is the opposite, or the y value, divided by the hypotenuse, and you can see that they're equal. So when we divide them, we get 1. The cosine is the x value divided by the hypotenuse. So 0 divided by a positive hypotenuse is going to be 0. Hypotenuse is always positive. And the tangent is the opposite, which is some positive y value, divided by the adjacent, which happens to be 0. And so if we divide some positive value by 0, we get undefined. So the tangent of 90 degrees is undefined. The cotangent will be the adjacent value, which is the x value, divided by the y value. So 0 divided by some positive number is going to be 0. The secant is the hypotenuse divided by the adjacent, so some positive r value divided by 0, because the adjacent side x for 90 degrees is 0. That will be undefined. And finally, the cosecant is the hypotenuse divided by the opposite, or the y value, And so again, the hypotenuse and the y value are equal to one another. When we divide these, we get 1. Now at 180 degrees over here, the hypotenuse, r, is equal to negative x. Right, so x is some negative value, and the opposite of that negative value is a positive value. The hypotenuse will always be positive. So to say that r is equal to negative x, if x is negative, that means that r will be positive. And so for 180 degrees, the sine is the opposite, or the y value, divided by the hypotenuse, which is always positive. But at 180 degrees, the y value is 0. So 0 divided by some positive hypotenuse is 0. The cosine is going to be the x value, which is negative over here, divided by a positive hypotenuse. And since they are equal, when we divide them, one of them is positive, one of them is negative, we will get negative 1. The tangent is the opposite value, which is 0, divided by the hypotenuse, which is some positive value, and so when we divide them, we'll get 0. The cotangent is the adjacent side divided by the opposite side. The adjacent side is negative, but the opposite side is 0, and so if we try to divide them, we will get undefined. We'll have 0 in the denominator. The secant is the hypotenuse divided by the adjacent value. The hypotenuse is always positive. The adjacent value is negative at 180 degrees, and they're equal, but they're opposite signs. So when we divide them, we will get negative 1. The cosecant is the hypotenuse divided by the y value, and so we're going to end up dividing by 0. This will be undefined. Finally, at 270 degrees, the sine will be the y value, which is a negative, divided by the hypotenuse, which is a positive. And so I should point out that the hypotenuse and the y value here have the same absolute value, but the opposite side is a negative value, whereas the hypotenuse is always positive. And so the sine being y over r, y is negative, r is positive, but they're equal in value, they're just opposite in sign. When we divide them, we will get negative 1. The cosine is the x value divided by r. X is 0, r is some positive value. When you divide them, you get 0, because we have 0 in the numerator. The tangent is going to be the opposite divided by the adjacent. So a negative y value divided by 0, that's undefined, because we're dividing by 0. And the cotangent is going to be the adjacent side, which is 0, divided by some negative value, which is y. And so 0 divided by any value is 0. The secant will be the hypotenuse divided by the x value, and so again we're dividing by 0, so that's going to be undefined. And then lastly we have the cosecant, which is the hypotenuse divided by the opposite side, and the opposite side is y, and it's negative, but they're equal, so when we divide them, a positive by a negative and they're the same number, we will get negative 1. And so now we have an idea of what the value is of all 6 trig functions when they lie on the axes, and we also saw what the values or the signs of the values would be when they lie in one of the 4 quadrants, either positive or negative. This is example 4. It says find the sine, cosine, and tangent of theta for a terminal side that passes through a point -3, 4. And so on a coordinate plane, we have the x and y axes. We have a point -3, 4. -3 is the x value. -3. 4 is the y value up here. And so the point is right here somewhere. So this is the angle that we're looking at. You can see that the angle is greater than 90 degrees, but less than 180, so it's in the second quadrant. And so the coordinates of the point that the terminal side passes through is -3, 4. And so the sine, before I do that, let's find the hypotenuse first. The hypotenuse will be the square root of x squared plus y squared. The hypotenuse will be the square root of -3 squared in parentheses plus 4 squared. So r is equal to the square root of +9 plus 16, which is the square root of 25, which is 5. So the value of r is 5. So r is 5, x is negative 3, and y is 4. So the sine of theta is y over r. Y is 4. R is 5. The sine of theta, whatever this angle happens to be, is 4/5. Cosine of theta will be x over r. X is negative 3. R is 5. And so whatever angle theta is, the cosine will be negative 3/5. And finally the tangent of theta, which will be y over x. Y is 4. X is negative 3. And so usually we like to have the negative in the numerator rather than the denominator. The tangent of this angle will be negative 4 over 3. Now the problem didn't ask us for cotangent or the secant or the cosecant, but I do know that these values are the reciprocals. So cotangent is the reciprocal of the tangent, it'll be negative 3/4. Secant is the reciprocal of the cosine, so it'll be negative 5/3. And the cosecant is the reciprocal of the sine, that'll be 5/4.